Hey guys, so in today's lecture, we are going to start this new chapter that is rating, testing, and performance. So, the basic task and development of IC engine, if we are going to develop an IC engine, then the basic task would be to reduce the cost of the production and to improve the efficiency because the IC engine already exists, so we need to improve its efficiency and power output. So, in order to achieve this goal, we as an engineer have to compare the engine developed by us if we are going to develop any other new engine in terms of various parameters to the existing engine. So, which parameters are considered as performance out performance parameters or efficiency? So, to test the engine and make measurements which we need to measure are very large. So, in this chapter, we will consider only important measurements and tests. So, which are the parameters which we can measure? So, with the development of this IC engine and their testing procedures, so what is our aim for measuring this parameter? So, our objective is I will divide the objective in three parts. So, objective number one, to get the specific information which cannot be possibly determined by calculation. So, experiment information uh, which cannot be calculated. Second, to justify the rating of the engine, that why the rating which we got by testing is appropriate. So, and the guaranteed specific fuel consumption, that how much specific fuel is being consumed. Third is to verify and confirm the validity of engine data. So, the validity of engine data used in designing the engine. So, that is to confirm the actual performance matches the specification given in the booklet or anything. So, which all are the parameters which we are going to measure? So, important parameters of IC engine which we are going to measure, which we are going to discuss in today's lecture, will divide in few categories. So first is friction power, then second is indicated power, third is brake power, fourth is fuel consumption, then fifth is airflow, then sixth is speed, then seventh is exhaust and coolant temperature of exhaust and coolant, then eighth is emissions, and ninth is noise. So these are the various parameters which we are going to discuss. So let's start with any of the parameters, but before starting that, we will discuss the Indian standard code for testing of engines. So one standard codes is given, that is Indian standard code, IS standard code ISO, from 1000 10,000 to 10,004 for testing of engine. So this is divided in, this is divided in from part 1 to 11. So there are total 11 parts from 10,000 to 10,004. So we'll discuss each and every IS code. So let's start with the first IS code. So IS code, then parts, and then details. What is the details for that IS code? So first IS code, that is 10,000. Then part 1. So in part 1, the details glossary of terms related to test methods is been given, that what are the test methods in there. Then in part 2, the standard reference conditions, so in which conditions the test has to be performed. So standard reference conditions. Then part 3, measurements for testing. So measurements for testing, units and limits of accuracy, and limits of accuracy. Then in part 4, the declaration of power, that how much power is being produced, efficiency, then specific fuel consumption, how much fuel is being consumed, and lubricating oil consumption, that oil how much it is being consumed. So this is up to part 4. Then will come part 5. So in part 5, preparation for tests, preparation for tests and measurement of wear, that what is the wear rate of the components, so that also we need to measure. Then recording for test results, then recording for test results, all the results how it should be recorded. Then 7, governing test for constant speed engines. So seventh part was governing test for constant speed engines. So the seventh part is, there is governors or governing test for constant speed engines. Also the selection of engine for use with electrical generators. So engine selection and governing test. So it will come in part 7. Then in part 8, the performance test has been held. Performance test. Then in part 9, so endurance test procedures both for constant speed and variable speed engines. So it is performed after tests specified in part 8 of endurance test is being carried out. That is, endurance test is being carried out, and for 32 cycles, in which each cycle is for 16 hours continuous running. Before start of next cycle, the temperature of oil sump is brought down to within 5 degree Celsius of its initial temperature. So endurance test for variable speed engine is conducted for 10 cycles, that is for around 100 hours, in which each cycle is of 10 hours, with the interval of 2 hours between cycles, 10 hours duration, with the interval of 2 hours between 10 hours duration cycle is divided into 5 cycles of each 2 hours duration. So results obtained are corrected to the standard reference conditions and compared to the results of sixth part, that is recording the test results. Then 10th part, there is test for smoke levels. It is the at the exit, the smoke which is coming out of the engine, so for that test. Then 11th, information supplied by the manufacturer, test certificates, that what are the certificates provided by the manufacturer. So this 12 parts come in ISO 10,000. Then next is ISO 10,001. So in this, that is part 11. So in this deals with, it deals with the specification for performance requirement for constant speed diesel engine up to 20 kilowatt capacity for diesel engine. Then in 10002, so same as above, but the engines above the capacity for 20 kilowatt above. So below 20 kilowatt is 10,001 and above is 10,002. Then comes 10,003. So in this it deals with the specification performance requirement of variable speed diesel engine. It is variable speed diesel engine for automotive purposes. So these two were for constant speed, and this third is for variable speed, that is for which we use for automobile purposes. Then come 10,004. So specification performance requirement for variable speed spark ignition engines, that is SI engine. So that is for petrol engine, variable speed. So these are the various ISO standards which were decided for this all categories or this all information. Now we will see next is indicated power, that is IP. So what is indicated power? So we will see that is indicated power. So an indicated power of an engine is the power developed within the engine. So in order to determine the indicated power, it is necessary to plot a PV diagram representing the actual conditions of the engine within the cylinder, since the area of the PV diagram gives the work developed by the engine. So if we draw a PV diagram, and in that area, whatever the area is, that will be the work done by the engine. So knowing the speed and the type of the engine, the rate of work developed can be calculated. So the apparatus used for actual P diagram is called engine indicator. So that is engine indicator. So in order to estimate uh, the indicator power of an engine, few methods are used. So first is use of indicator diagram. The second is by adding two measured quantities, that is brake power and friction power. Third is Morse test. These are the three methods to find the indicated power. So engine indicator consists of, so we will see the first indicator diagram. So for that engine indicator consists of a cylinder, piston rod, and on a cylinder coupling nut is fitted, and the coupling nut is connected to the gas hole tap, which is fitted to the cylinder head of the engine to be tested. So so this is the diagram of engine cylinder. So this consists of a piston. So this is the piston and a piston rod. So this is the piston rod, and on the cylinder a coupling nut is fitted. So on this cylinder, this is the coupling nut which is fitted, and the coupling nut is connected to a gas hole tap. So this is connected to a gas hole tap which is fitted to the cylinder head of the engine to be tested. So which engine is to be tested, so that is fitted. So the gas tap connects through passages both to the cylinder of the indicator and to the combustion chamber of the engine cylinder. Now the piston slides in the cylinder. So this piston slides in the cylinder, so it slides inside the cylinder, and the piston rod is connected to a straight line linkage through a spring. This piston rod is connected to a straight line linkage through a spring. So there is a spring here in between. So connected through a spring of a proper stiffness. So it is having a stiffness which is required. The straight line linkage is mounted on a swinging collar. So this straight line linkage, so this is the straight line linkage which is mounted on a this is mounted on a swinging collar. So this is the swinging collar, so above which it is mounted. So is mounted on swinging collar which can rotate on the top of the indicator cylinder. So this can rotate on the top of the indicator cylinder. Now this is the drum. This is the indicator card. So which where the diagram is to be drawn, and this is the indicator diagram. This is the stylus, so which will draw the diagram, and this is the pulley and cord attached to a hook. Now the spring controls the movement of the piston. So this spring controls the movement of piston according to the pressure of the engine. So as the pressure increases or decreases, the spring controls the movement of the piston. So a stylus, so this is the stylus, is attached at the end straight line linkage. So it is attached at the end straight line linkage. So this end is attached straight line linkage so that it moves in a vertical line. So this move is in a vertical line, so it moves up and down, and this drum is rotating, so up in a proportion to the movement of the piston, to the proportion of the movement of the piston, by magnifying its movement. So as the piston moves up and down, so this string linkage also moves up and down, but it is magnified. So if it is moving 1 centimeter, then this will move 10 centimeter. So some magnification is given, is provided. So it is provided here due to this linkage. So a drum. So this is a drum which to which a paper or an indicator card. So this indicator card or a paper uh, it is fixed and is mounted on a vertical spring and shaft. So this is mounted on a vertical spring or the shaft, spring and the shaft. So it is rotated by a cord. So this is rotated with the help of this cord. uh, so it is rotated by a cord wound around it. So this cord is wounded around this drum. So in the other end of which it is attached to a point on the engine whose motion is same as the piston of this cylinder. So this the other end is wound. The other end is attached to the point on the engine whose motion is same as the piston of the engine cylinder. So the vertical movement of the stylus. So the stylus is move vertical up and down, and the horizontal movement of the cord, and this horizontal movement of the cord, that is this cord move in this direction, combines produces a closed figure of the indicated diagram. So this will produce a closed figure of the indicated diagram. So the area enclosed under the indicated diagram measures the work developed during a so this produces a work developed during a stroke to a definite cycle. So it should be noted that the stiffness of the spring is chosen appropriate to maximum pressure in the cylinder. And this type of indicator is not suitable for measurement in case of high speed engines due to its mechanical nature. Usually these are found suitable up to the speed of 1500 rpm. Up to 1500 rpm we can use this diagram, this method. Okay, so this is one type of indicator machine which will produce an indicator diagram. Now let's draw a indicator diagram. So suppose this is the pressure P, volume V, pressure volume diagram. So such type of diagram will occur. So this is such type of diagram because so it represents a constant pressure which if it is acted over the full length of the stroke would produce the same amount of work by the piston, and is actually and this is actually produced by the engine cylinder during a cycle. So this is the area. So IMEP, that is indicated mean effective pressure, can be determined with the help of this diagram, and the area of the indicated diagram can be measured with the help of a planimeter. So the A is the, suppose A is the net area of the indicated diagram. L, so suppose this is the L. So L is the length of the indicated diagram, and K, suppose K is the spring stiffness. So therefore the mean height of the diagram, so mean height of the diagram will be A upon L. It is net area of the indicated diagram divided by length of the indicated diagram. So that will be the mean height of the diagram. So if you multiply it with K, so we will get indicated mean effective pressure, that is A by L into K. So that will be our mean effective pressure, A by L into K, or we can call it as K into H also. So this is the mean indicated pressure. Now indicated power. So now we'll see what is will be the formula for indicated power, that is IP. So indicated power, so suppose PM is the indicated mean effective pressure, IMEP. We will call it as small as PM. A is the cross sectional area, so A, that is pi by 4 d square. So uh, so here D is the diameter of the piston or bore, and L, suppose L is the length of the stroke. L is the length of the stroke length. N is the number of power strokes per minute. N is number of power strokes per minute. And so capital N is the speed of the engine in RPM, and small in power stroke per minute, as okay, N you say. So here we will use N by 2 for 4 stroke engine, as 1 power stroke per 2 revolution, and N for 2 stroke engine. So now let's calculate the mean inductive power. So force on the piston, so force on the piston will be pressure into area. This mean effective pressure into area, that is pressure into area is force. So work done on the cycle will be, that is force into displacement or distance, so pressure into area into how much distance is covered, so that is length L. So that is length L. So indicated power, so indicated power will be equal to PL AN, it is plan, we can call it also short form plan. Indicated power, length, area, n, what is n, that is number of power strokes per minute. And if we want to convert into second, so we will get PMLA n by 60. So we will get this in watt, and if you want to convert in kilowatt, so it will be 60,000, that is indicated power plan by 60,000. This is the formula for indicated power. So we will see the other terms, is brake power and frictional power, in the next lecture. So thank you very much.